principle and logical omniscience. But before we get started, I would like to thank to the organizers of the event, well, especially to my advisor, Max Hernández de Castro Tapia, who invited me to the event. And I will begin. Since the invention of post-modal semantics, modal logic applications have increased by developing logics alethic, tense, epistemic, doxastic, etc. However, many logicians also recognize that a modal logic that only considers one kind of modality is quite restricted. An example said once that the only way to have any philosophical results in the ontic logic or epistemic logic is to combine these operators with tense operators. Otherwise, how can you formulate principles of change, the logical operators? Otherwise, how can you compare the relative with the absolute, the operators like historical or physical necessity? Otherwise, how can you relate the agent to his environment, and so on and so on? Multimodal logics raise intending to consider the most ambits involved in the validity of inferences, such as time, place, knowledge, belief, obligations, etc. In this presentation, I will develop how we can use multimodal logic to criticize the validity of some instances of the closure principle for epistemic logic, and how these logics face the omniscience problem, but spoiler alert, they cannot solve it. Hence, I will also propose a pair of solutions by adding non-normal words and epistemic states to the semantics. All of the statements made in this work are developed in my current master's research, in which I also offer Tableau systems for the logic presented here. My synthetic approach here will be merely axiomatic. For brevity, I would take for granted that the audience is familiar with normal modal logic, specifically with alethic, tense, epistemic, and doxastic logics. The languages for serious modal logics only differ on the operators they handle, and their cryptic models differ on the sets they take for basis. You can see them on the table 1. Nevertheless, I would like to make a pair of remarks before starting. First, when we use tense logic, it is customary to modify a cryptic model slightly. Instead of using a set of words and an accessibility relation R, we use a set of times T and a succession order for them. This slight change does not happen when we move on to epistemic or doxastic logic. In those cases, it is customary to use cryptic models without changes. In other words, it is typical to still use W. I think this practice is wrong. I suggest that in epistemic and doxastic logic, we should also slightly modify cryptic models utilizing a set of epistemic states E. Certainly, this remark is more philosophical than technical. We can get the same results by ignoring it, as we shall see below. However, the philosophical discussion gets a new path to follow if we adopt the change. The second remark concerns two definitions not very common in literature. The first one is for contingency, something it's contingent if it's possible, and so is its negation. And the second is for always in tense logic, something is always the case. If it has always been the case, it is the case now. Oh, that was unfortunate. And it's always going to be the case. Sometimes operator is defined as the dual of the always operator. In this presentation, we will be working mainly with an alethic epistemic doxastic language, which is a union of the mentioned languages and clearly is more expressive than any of its components. This language can be used to explore both our epistemic and doxastic attitudes toward alethic logic. For example, to believe something is contingent strictly implies it is not known as necessary, and the alethic modality of our knowledge and beliefs. For example, if an agent knows phi and it's possible for phi to be false, then it is contingent for our agent to know phi. This last statement was true. As an explanation, I will do you want me to continue or do I wait? Well, I shall proceed. Well, the basic multimodal logic I'm going to develop here is called TTKD star, whose axiomatic system is the one shown in table 2. For the axioms, we will take all the tautologies of classical propositional calculus, the closure principles for necessity, knowledge, and belief, and we will also accept the Theoletic axiom, the epistemic axiom, the doxastic axiom, and KD axiom. Knowledge implies beliefs. And for the rules, we will take uniform substitution, modus ponens for material implication, and the necessitation rules for necessity, knowledge, and belief. If phi is a logical truth, then it's necessary and it's known and believed by our agent. An interpretation for the TTKD language, which is the union of the languages, is the structure WERECKW, CBW, nu, where W and E are non-empty sets of possible worlds and epistemic states. RE is an alethic accessibility relation relativized to epistemic states, which is relatively reflexive. CKW is an epistemic accessibility relation relativized to possible worlds, which is relatively reflexive, and CBW is the same for belief, and it is relatively serial. And finally, nu is a map from world epistemic states propositional parameters tuples to the set of the classical truth values, true and false. The truth conditions for the element of the language are pretty similar to those for alethic and epistemic logic. We only need to do a proper relativization to worlds and epistemic states. The semantic validity is defined by means of truth preservation through worlds and epistemic states. And the soundness of the axiomatic system is easy to prove, for the relativization of truth conditions does not affect the validity of the elements of the systems. A theoretic interpretation of TTKD is one. A theoretic interpretation is one of TTKD, where E is simply E0, and a TKD star interpretation is one of TTKD, where W is simply E0. Indeed, this fact suggests that we usually study alethic logic impersonally, and that epistemic doxastic logic is not studied beyond one single circumstance. Now, I would like to say a few words about the origin of TTKD fusion semantics. It all began with the semantics for analytic tense logic called MT. An interpretation for the MT's language, which is the union of alethic and tense language, is the structure WTRT succession W, nu, where W and T are non-empty sets of possible worlds and time. RT is an alethic accessibility relation relativized to times, which captured the idea that possibilities change over time. Its motivation are sentences such as, in 1932, it was possible for Great Britain to avoid war with Germany, but it was impossible in 1937. Succession W is an ordered succession for times relativized to worlds, which captured the idea that every world has its own temporal order. Nu is a valuation function as usual. A special feature of MT is that by allowing different time orders for each world, MT invalidates inferences such as, if there is always a future moment in time, then it's necessary to there be always a future moment in time. For even if there is always a future moment in time in the actual world, maybe there is another unfortunate world where time ends. By analogy, I believe that it was possible to build the semantics for analytic epistemic logic changing T for E. So RE would mean that alethic accessibility relations should change over epistemic states, and CKW would mean that epistemic accessibility relations should change over possible worlds. But what did not expect was the following consequence. By relativizing R and nu to E, we get an actualist reading of alethic logic. Possible word semantics only make sense inside an agent's mind. Naturally, one might ask, do we need E to have analytic epistemic doxastic logic? And surprisingly, technically speaking, we do not. Daniel Ronedal, for example, has developed a quantified temporal alethic boolesic doxastic logic that only requires W and T. Without constraints, a model for its logic is the structure DWT, succession, fracture R, fracture A, fracture D, nu, where D is a non-empty domain of set of individuals, W and T are non-empty sets of possible worlds and times, succession, unlike in MT, is an absolute order for time, fracture R is an accessibility relation relativized to times, like RT, fracture A is a boolesic accessibility relation relativized to individuals in the domain and times, and fracture D is a doxastic accessibility relation for every individual in the domain, and nu is a denotation function as usual for first order modal tense logic. In this conceptual framework, alethic, doxastic, and boolesic words are only distinguished by accessibility relations. Hence, E is not necessary to build up an alethic epistemic doxastic logic. However, one might wonder why we should only need W. When we use alethic tense logic, we distinguish word from times, and it would be strange not to do so. Therefore, why we should not distinguish between words and epistemic states? To me, that's the most natural thing to do, and it brings us an actualist reading in a natural way. Now we can pass to a strict closure. Just like in modal logic, to have an axiom or theorem with material implication does not guarantee the validity of the same principle with a strict implication. The axioms Theoletic, epistemic, doxastic, and KV are valid with the strict implication in KV. However, none of the closure principles is valid with the strict implication. The strict closure for necessity is valid if the alethic base is S4, but the other closure principles are still valid. Nevertheless, if the alethic base and epistemic bases are S5, the strict closure for knowledge is valid. However, the strict closure for belief is not valid even on this basis, nor even if the base for doxastic logic is KD45 star, as we can see in the table. If we accept S5 as basis, besides the obvious additions, we add the following principles to the axiomatic system. SH states that if it is necessary for our agent to know a proposition, then our agent knows it is necessary, and SH converse states that if our agent knows something is necessary, then it is necessary for her to know it. Then the axiomatic proof for the strict closure for knowledge is straightforward, as we can see in table 4, because on the first line, we accept the closure in its material version, and then we apply the necessitation rule, and then the closure for necessity. So on the line 3, we will have that if it is necessary for our agent to know a material implication, then it is necessary that her knowledge of P will imply her knowledge of Q. And the crucial point comes in the line 4, where we have SHC with uniform substitution. So if our agent knows it is necessary that P implies Q, then it will be necessary for her to know the material implication. And by a hypothetical syllogism between the lines 3 and 4, we will have that if our agent knows it's necessary an implication, then it will be necessary that her knowledge of the antecedent will imply the knowledge of the consequent. And by a further application of necessitation rule and the definition of a strict implication, we will have the strict closure for knowledge in line 6. Now, in alethic tense literature, it is usual to distinguish between absolute necessity, when something is always necessary, and historical necessity, when something is necessary at some particular time. For example, it is necessary at some past time, it was necessary, it will be necessary at some future time, or sometimes it is necessary. By analogy, in alethic epistemic frameworks, we should also distinguish between absolute knowledge, with the pardon of Hegel, and when our agent knows some things under all circumstances, and relative knowledge. Then the above principle can be read as present in table 5. SH, it states that absolute knowledge of something that is under all circumstances implies its knowledge as necessary, and HAC states that the knowledge of something necessary implies its absolute knowledge, that is, the agent knows it under all circumstances. Now, even if SH and SHC are valid in S5, S5, one might doubt their plausibility. SH fails if we think a la Hume, for even if we can have an absolute knowledge about something, we cannot conclude that we know it as necessary if we can conceive it as possibly false. The issue is that Hume thought about this over time to deny the induction of future events. Even if you always knew that the sun will rise from the east, you cannot know that it will always do if you can conceive that it will not at some future time. SHC fails because even if we do not know, even if we know something as necessary, we can also conceive a situation where we do not know whether it is true. This is kind of disappointing for a logician, for she has finally found the holy grail of her theory, the knowledge of a necessary statement. However, that does not imply she necessarily knows its propositional statement. Maybe there is a world where she never cared about it. Now, a well-known critique of the closure principle is due by Fredretzke. He believed that the closure principle is alettically admissible, but not epistemically, for epistemic implication is not as penetrant as alethic implication. A justificatory case for this statement is the following. The definitions and postulates in Euclid elements necessarily imply all the propositions in the elements and more. However, knowing this implication does not imply that the knowledge of the elements, definitions, and postulate imply knowing all the theorems in the elements and more. The failure of SHC in TTKD and consequently of the closure of the strict closure for knowledge makes substantial Dredske ideas. There are some circumstances where our knowledge can fail, even if it is initially about something contingent. On the assumption that a strict implication models the conditional for natural languages, any system whose alethic base is S4 and whose epistemic base is weaker than S5 catches Dredske intuition for the strict closure for necessity is valid, but the strict closure for knowledge is not, and the same applies to the doxastic case, mutatis mutandis. Now, to finalize this presentation, let us see how alethic epistemic logic faces the omniscience problem. A usual critique to epistemic logic is that it implies the agent to be perfectly rational thinkers. Properly speaking, it is problematic the following consequence, the following inference. Material omniscience states that if it is valid that phi materially implies phi, C, then the knowledge of phi will imply the knowledge of C. Now, material omniscience is clearly a consequence of the necessitation rule for knowledge and the closure principle for knowledge. The former makes our agent know all classical tautologies, and the latter allows her to close her knowledge under material implication. Given the fusion semantics for modal logic, it is natural to wonder whether we can have a new version of logical omniscience, namely a strict one. So a strict omniscience is that if it is valid that phi strictly implies C, then it is valid that the knowledge of phi will strictly imply the knowledge of C. In TTKD, we have the strict modus ponens. If phi strictly implies C and phi is valid, so is C. In S5, KD Fourier star, a strict omniscience clearly holds, as we can see in table 6, because suppose we have a valid material implication. By the necessitation rule, we will have it we will have a valid strict implication, and by the necessitation rule, we will, for knowledge, we will have that our agent will know that strict implication. By the strict closure for knowledge and strict model exponents, we will have that the knowledge of E will strictly implies the knowledge of C. So we will have a strict omniscience. Given the failure of the strict closure for knowledge in TTKD, it is expectable its failure in the strict omniscience. However, that it's not the case, for in TTKD we have a quasi-strict closure principle that it says that if it is necessary for our agent to know a material implication, that will imply that the knowledge of C strictly implies the knowledge of C. So in TTKD, a strict omniscience also holds. Suppose we have a valid material implication. By the necessitation rule, we will have the material, the strict implication as valid, but that's not the problem. The problem will come when we apply the necessitation rule to the material implication, and then the necessitation rule for necessity. So by the quasi-strict closure principle and strict modus ponens, we will have that the knowledge of C will strictly imply the knowledge of C. So we will have also the strict omniscience. By now, the easiest way I know to avoid the strict omniscience is to add non-normal words or non-normal epistemic states to the semantics. Let epsilon be either a normal or non-normal word, and epsilon be either a normal or non-normal word. Now the three conditions for the modal operators are the following. If we are in a non-normal world, the necessity operator will be false. And if we are in non-normal epistemic states, the epistemic operator will be false. Still, the definitions between operators is still valid, and the semantic validity is defined by means of truth preservation through normal words and epistemic states. Now we are in position to choose, because if we accept non-normal words to the semantics, the necessitation rule for necessity will be invalid, and so it will be the strict omniscience. And on the other hand, if we add non-normal epistemic states to the semantics, the necessitation rule will be invalid, and so they will be the strict omniscience and the material omniscience. Hence, we will have two options to make a strict omniscience fail. Now, are non-normal words different from non-normal epistemic states? I am tempted to say that they are. Even more, if normal possible worlds are different from normal epistemic states, the same things must happen when considering non-normal cases. So here are two proposals for what can it be one or another. Some logicians, for instance, Grand Prix, claim that impossible worlds are worlds where logic laws can be different, so that a world may be ruled by classical logic, but in other, intuitionistic logic is right. So even if double negation elimination is valid with strict implication in the actual world, it is false that it is necessary true. Now, on this basis, in a multimodal conceptual framework, non-normal worlds also affect the other's logical truths. It is easy to see that if we accept non-normal worlds, it is false that it is necessary that knowledge strictly implies belief. And on the other hand, Hintika believes that among our epistemic states, sometimes we admit inconsistencies. So some epistemic states have contradictions without noticing. That is why we usually take by false some logical truth. For example, the positive introspection of the possibility axiom is false if we accept non-normal epistemic states. So to summarize, here are the conclusions. The TTKD language is more expressive than the languages of its components, and it allows us to study our epistemic doxastic attitudes towards alethic and towards alethic logic, and the alethic modality of our knowledge and beliefs. The fusion semantics for TTKD gives a natural actualist reading of alethic logic by relativizing R and nu to E, and this move is legitimate by analogy to the fusion semantics for alethic tense logics. The strict closure for knowledge is only possible in S5, S5 due to the validity of SHC. The knowledge of a necessary proposition implies its absolute knowledge. Dretsche's ideas on the failure of epistemic closure get the substances with alethic epistemic logics for subsystems may have a strict closure for necessity without a strict closure for knowledge. And the failure of the strict closure for knowledge does not solve the omniscience problem. However, we have two ways to solve the problem. If we add non-normal words to the semantics, so necessitation rule for necessity fails, and if we add non-normal epistemic states to the semantics, the necessitation rule for knowledge will fail. So the decision is up to the logician conviction that words and epistemic states are different, both normal and non-normal. And that will all for my presentation. Here is my minimal